Here we have the diagram of our inverter circuit. As you can see, here we have the driver circuit. Here we have the switching circuit, all this part, and then we have the feedback. That part is used for feedback. Now in this circuit, this feedback permits such that when the voltage of the battery drops below a certain value, it permits to turn off the MOSFET due to the fact that the voltage could drop lower than the threshold voltage of the MOSFET and could damage the MOSFET if the system is not turned off. And at that instant, the pulse width modulator will detect the voltage and will automatically turn off the circuit. So that is basically the function of the feedback loop. We notice that terminal 14 and terminal 11 is responsible for carrying the signal generated. See the signal, 2 signals, 6 volt that drives the MOSFET, which produces alternating current to drive the transformer, generates 220 volts for the output. Here we also notice that the frequency of this circuit is ensured by the resistor RT, this resistor, and this capacitor CT. And the frequency is given by 1.3 divided by the product of RT times CT. As we can see, 1.3 divided by RT times CT. Our RT is 250,000 ohms and our CT is 0.1 microfarad. The 1.3 divided by 250 times 10 to the power 3 times 0.1 times 10 to the minus 6, which should give us 52 Hertz. So that is the frequency of this inverter circuit. We directly start building our inverter. So here we have the breadboard. We're directly going to mount the pulse width modulator. That's the integrated circuit we use, SG3524N. Currently going to mount him on the breadboard. Pulse width modulator has been mounted. We'll go to mount the resistor, the 10k ohm resistor. 10k ohm resistor on terminal 1. The 10k ohm resistor is mounted. Go directly to mount the 4.7k ohm resistor across terminal 2. A 4.7k resistor has been mounted. We'll go directly to mounting our 0.1 microfarad capacitor on another 4.7k ohm resistor. We have mounted our resistor. I'm going to use some cables to complete the circuit. Go to terminal 16 and see. Similarly to mounting our timing resistor RT 250 kilo ohm. We shall mount two 100 kilo ohms in series and two 100 kilo ohms in parallel to have 250 kilo ohms. Mount 100 kilo ohm. On the second 100 kilo ohms, that gives us 200 kilo ohm. Now we're going to mount the timing capacitor, 0.1 microfarad, 104. Mount 0.01 microfarad and a 20 k ohm resistor between terminal 9 and the ground, which is terminal 8. Mounted our capacitor of 1 nanofarad, 0.001 microfarad, and 20 k ohm resistor. Now connect it to the terminal 8, which is the ground. And we're going to connect terminal 4 and terminal 5 to the ground. use our ground cable. Our ground cable. I'm going to connect the 1K ohms. And the 1K. We're going to connect our 12-volt supply. Now we have read our driver circuit. And worked our terminal 11 and terminal 14. I remove 6 volts. I'm going to connect terminal 11 and 14 for the pulses of magnitude 6 volts and frequency of 52 Hz to drive the MOSFET. Circuit is okay. Now we have to test the circuit with the 12-volt battery. Now we have 12.55 volts, which is okay. Connect the mass. Connect the positive. Our circuit is okay. You can see 6.2, 6.3 volts across the two output terminals of terminal 11 and terminal 14. Just okay to drive our MOSFET.